A warm welcome to PD 5110 class, Professional Diploma in Education class, specifically Educational Research and Statistics. This is the 14th lecture series, and the topic we'll be looking at today is validity and reliability. Just before this particular lecture, we looked at research instruments we use in data collection. So here we want to also work on that, proceed by looking at validity and reliability. Validity and reliability are two concepts you must ensure before using an instrument for data collection. So we'll start with the first one. What is validity? Validity is the extent to which an instrument measures what it's supposed to measure and perform what it is designed to perform. So when you have an instrument that you call an instrument, any of the instruments, if you call this a test or call this a questionnaire, it must be measuring what it aims to measure. So it is rare, however, if nearly impossible, that an instrument be 100% valid. So validity is generally measured in degrees. The closer it is to 100, the better. Though it may not be perfect as 100, but the closer it is to 100, the instrument, it can be adjudged good enough, very good enough to collect the data that is intended to collect. So as a process, validation involves collecting and analyzing data to assess the accuracy of the instrument. There are numerous statistical tests and measures to assess validity of quantitative instruments, which generally involves pilot testing. You will recall that we said pilot testing is when you're doing a trial test. You're doing a trial test of an instrument before you use it for the full exercise itself. You have to ensure and see how well it's as good as conducting a miniature class. Again, pilot testing is doing a miniature test before the full length of test which is meant to be carried out. You try to select some few participants, give them this instrument, and see whether they will react the plausible way you have expected them to react to the instruments. So when you do that and they actually react, then it means that it's good for the main exercise or the main study itself. Types of validity. What are the types of validity? We have the ones we look at is phase validity, content validity, construct validity, and criterion related validity. Phase validity is concerned with how a measuring instrument appears. Is it looking the way it should look at? If it's called as a questionnaire, you ensure that it's looking like a questionnaire. If it's a test, you must ensure it's wearing the features of a test and not otherwise. So an instrument, that's for phase validity. While the next one is called content validity. When is an instrument being content valid? An instrument is said to be content valid if the instrument represents the entire range of possible content the instrument should cover. For instance, if I am to give a test on math, what are the topics I taught? The topics I taught, is it well represented in the test given to the learners? If it is well represented, questions are adequately asked on each of the topics that has been taught for the term, then we say it is content valid. Similarly, if you have a questionnaire that is meant to measure attitude, is it containing statements? In the questionnaire, is the questionnaire containing statements that is asking question or that is asking the respondent's opinion about their attitude towards possibly learning, which is what the researcher intended. If it is doing that, then we say it is content valid. Can also be what? Construct valid. When is it construct valid? This instrument is said to be is said to measure construct validity if it measures the relationship between test score and the prediction of a theoretical threat. So, of course, we expect, for instance, you have a theoretical threat, you want to look at maybe an IQ of certain respondents, and you try to give an instrument on that. How well the learner responds, you'll be able to predict the intelligence quotient of the learner. Then you say it is construct valid. Similarly, we can also have another one, which is the last, which is a content criterion related validity. This refers to the ability of an instrument to predict the performance of respondents when correlated with an already validated instrument. So meaning under criterion related validity, we will have a particular instrument that has possibly been standardized, then we have our own. So when doing criterion related validity, there are two types of criterion related validity. There are two types we do under criterion related. Don't forget we said there must be one that is standardized and there must be another one that is being constructed. I'll give a small instance. A small instance is, well, imagine you want to ensure the criterion related validity of a test item you develop as a teacher. I'll give an instance of one of the standardized exams, which is WAEC. You form the WAEC question. You following the marking guide of mathematics for WAEC, you draw your question as a teacher, and you also pick one of the past questions of WAEC. You want to see if what WAEC question is doing, your instrument you develop as a teacher can also do the same. Then we call that criterion related. So, however, there are two types of it. The first one is if you give those two instruments to the respondents at the same time to respond to, and you collect the two scores. Maybe you give it to a sample of 30 students, you collect the scores, you scored it, and you run Pearson product moment correlation coefficient on them. If it's as high as 70% and above, or 0.7, between 0.7 and 1, then we say that the instrument has concurrent validity. It has concurrent validity. So here, both the one you develop as a teacher and the standardized instrument is given together to the respondents to respond to. After computing the Pearson product moment correlation coefficient, and the score derived is as high as 0.7 to 1, then we say it has a concurrent validity. The second example of the criterion related validity is when you give the teacher made test, for instance, first. You want to use it to see if they haven't attended to it. You want to see if later if they attended to a standardized score. If that particular teacher made test you give first can predict the performance of learner in the standardized test. A clear example of that is the one we give during WAEC. If a student is running WAEC, there's something school trying to prepare their learners towards. We call it a mock exam. You give a question during mock such that you use that to practice, and when the main exam comes, which is WAEC, we want to see if the two scores here, the first the one you gave, which is the teacher made test during mock, and the one done by WAEC, you try to see and do a Pearson product moment correlation and see the performance of the learner. If it is as high as 0.7 and above and 0.1, we say it has high predictive validity. So we are saying that anybody that is doing well during mock will also do well during the main exam. Then that particular validity is called predictive validity. So a quick recap here on the validity. Having explored all the types of validities, that whenever we are to give an instrument on the field as a researcher, we must ensure that that instrument is valid. And how do we then ensure? We can use either of these four types of validity that we have mentioned in ensuring that it is valid, that it is measuring what is expected to measure. Having said that, it is not only for us to ensure that it is measuring what is expected to measure, we must also ensure its reliability. It must consistently be given equal level of result. That takes us to reliability. This refers to the ability of an instrument to consistently produce equal level of results. Thus, the reliability of an instrument, a research instrument, concerns the consistency in which the instrument yields the same results on repeated trials. So if you try the first, after repeated trials, it must be giving you the same results. The type of reliability we can ensure. Basically, we ensure the stability of an instrument, we ensure the internal consistency of an instrument, and finally we ensure the equivalent form of an instrument. The first one, starting with stability, the type of one we use in ensuring stability is what we refer to as test-retest. Test-retest reliability is used to ensure stability of an instrument. It is obtained by administering a particular instrument twice to the same respondents with a given time interval. I'll give a small instance here. An instance whereby during your pilot testing, you give an instrument to a respondent, and the instrument you give to the respondent, you give them at first, maybe a group of respondents of 30. You give them the first time you're giving them, you give them the test. 2 weeks after or 3 weeks after, you give them the same test again. You must have derived two scores, pairs of scores. By the time you correlate using Pearson product moment correlation coefficient to determine the correlation coefficients, if we get between 0.7 and 1, that shows that the instrument is stable over time. So that will give us the correlation coefficients will enable us conclude that it has a high stability. Then that such can be used for the main study. To ensure is what we call internal consistency of an instrument. Internal consistency. One of those ways we can ensure internal consistency is what we call split half method of reliability, which is derived by administering an instrument to a group of students, say 30 of them. You give them to them once. Thereafter, you collect the instruments back from them. You divide the score into halves, evens, and odd. I'll give an instance here as we proceed. While trying to conduct a split half is easier when it is a test. If a test item is given, give a test of 40 items to group of learners. While you give that to them, after administering the test on the student, maybe 30 of them, a 40-item test, you collected it from them. What you do next is to mark the test. After marking, then you separate the items into two, the ones that falls in the even and the ones that falls in the odd scores. So those scores will be marked. Of course, because it is 40 items, you have 20 each. So a learner or a respondent will be having two scores for even while scores for odd. Thereafter, those two sets of scores will be subjected or will be computed to get the correlation coefficient using Pearson product moment correlation coefficient. Having done that, the scores that is being derived, then there will be need to also subject it, because we have divided it into two, in order to correct the correlation coefficient to its full length. Spearman-Brown prophecy formula is used to correct the length. When that length is corrected, we will then have the full correlation coefficient that reflects the instrument. In this case, if the correlation coefficient is between 0.7 and 1, then we say that that particular instrument has a very good internal consistency and can be used for the main study. Charting is another method by which we can also derive internal consistency in order to ensure reliability of an instrument. We have what we call the equivalent form reliability. Equivalent form reliability. This is a type of reliability which refers to the extent to which two test items measure identical concepts at an identical level of difficulty. How do we then ensure this? One, we form two test items using the same course content. So we can give an instance of a subject such as economics. You can have two sets of economics questions from the same course content. This test item is then administered to the same group of students, one after the other, without time interval between the first and the second tests. Thereafter, the two scores are collected and computed using Pearson product moment correlation coefficients in order to determine the correlation coefficients. The scores gotten, if it ranges between 0.7 and 1, then we conclude that it has an equivalent form reliability, meaning that the two test items can serve the same purpose. So in conclusion, when doing a reliability or when ensuring the validity and reliability of an instrument, we must ensure that the instrument is both valid and reliable. A small example, a small analogy here is you can give a test item or you can give an instrument for instance, you can give a test item to a physics test to a commercial student. You agree with me that the person you are giving it to is not valid because they are not the kind of learner you should give it to. However, it could be reliable because the learner will consistently get 0 because it's not a physics student. So we must ensure that it is valid. It's doing what it's supposed to do, giving it to the right set of people, doing what it's supposed to do, and also on repeated trials gets equal levels of results. So before a full before going with an instrument to the study, we must ensure we carry out validity and reliability of an instrument. Let me quickly relate this to our project work. When writing a research report under your chapter 3, we have a subheading there we call validity of instruments and reliability of instruments, meaning that the research instrument you have drawn, you must tell every reader that picks up your work that this was how you ensure that it was valid and it's also reliable before being used for the main study. Yeah, we'll stop the lecture here. All right, and we'll meet in the next lecture. Thank you for your attention, and bye for now.